This is the Space Shot, episode 28, for June 11th, 2017. Gamma rays, gemstones, and the Fermi Space Telescope. Hey everyone, welcome to the Space Shot, your daily space history, pop culture, and news fix. I'm John Molnix. Today we're going to be talking about gamma rays, and no, not the kind that transformed Bruce Banner into the Incredible Hulk, but the kind that the Fermi Gamma Ray Telescope is designed to observe. On this day in 2008, the Fermi Gamma Ray Space Telescope was launched from Cape Canaveral Air Force Station. Originally, the Fermi Gamma Ray Telescope was named the Gamma Ray Large Area Space Telescope, or GLAST. Not a very catchy name, but it was renamed in honor of Enrico Fermi. He was a pioneering physicist that was involved in everything from the Manhattan Project to the creation of the first nuclear reactor and other projects after the end of World War II. But before we talk about this space telescope, let's talk about what gamma rays are. A gamma ray is a type of electromagnetic radiation that was discovered at the beginning of the 20th century. Other types of electromagnetic radiation include X-rays, infrared light, visible light, anything on the electromagnetic spectrum. Gamma rays can be both harmful and helpful to human life. Gamma rays are used in numerous ways to help improve the quality of life, from surgeries to treating gemstones. Gamma ray knife surgery is a new type of therapeutic radiology that's extremely precise and is used to treat tumors and lesions that are usually located in the brain. Multiple super-focused beams of gamma rays converge on one point, minimizing the damage to surrounding brain tissue. Gemstones can be irradiated with gamma rays to create colors that are either very rare in nature or not possible in nature. Don't worry about the irradiated gemstones you might have because they don't pose any health risks. The field of gamma-ray astronomy started during the Cold War. The U.S. military Project Vela satellites that I talked about back in episode 4 detected the first gamma-ray bursts. These bursts are extremely violent celestial events, and they were first detected in the late 1960s. In July, I'll talk more about the Project Vela satellites and the first detections of gamma rays. So why do we need space-based detectors for gamma-ray astronomy? Well, Earth's atmosphere blocks out most gamma rays, which is why we need to have satellites. The Fermi Space Telescope is the newest gamma ray telescope, and after its 2008 launch and initial mission, Fermi started a 5-year extended mission that goes through 2018. The telescope is designed to survey the sky in the gamma ray spectrum, searching for black holes among many other objectives. The discoveries made by the Fermi Telescope team are incredible. In 2008, the largest gamma ray burst ever was recorded, and it was emanating from the constellation Carina. The gamma rays that were ejected by this gamma ray burst were moving faster than 99.9999% the speed of light, and are the fastest moving particles detected to date. Now for closer to home, the Fermi Space Telescope has been used to observe terrestrial gamma ray flashes, which occur naturally in thunderstorms. Earth-based thunderstorms are capable of sending antimatter in the form of positrons into space. The speed at which these TGFs, or the terrestrial gamma ray flashes, occur is staggering. Within 1.98 milliseconds of a lightning strike, the electrons and positrons that result from the TGFs are at a position that can be detected by the telescope orbiting hundreds or thousands of miles away. Fermi has detected hundreds of TGFs, and according to NASA, it's estimated that approximately 500 occur daily worldwide, but most go undetected. I'll link to some of the NASA science visualization videos in the show notes, so be sure to check those out. Sadly, under the most recent NASA budget estimate, the Fermi mission will not have funding past its original mission extension to 2018. As the budget process proceeds, I'll provide updates as they become available. Tomorrow we'll still be talking about Fermi, specifically his paradox. I'm grateful that you've taken the time to listen to the show. It would mean a lot if you could leave a review on iTunes and Google Play Music. If you know anyone that loves space, history, or pop culture, be sure to share the Space Shot on Facebook, Insta, Twitter, anywhere you connect with your friends and family. I'm John Molnix, and I'll catch you on the flip side.